Good morning, everybody. It's actually not really good morning anymore, right? It's 5 p. You've been so brave sitting in all those sessions. I can tell you a secret, 5 p is obviously a valid time of the day to start drinking beer, at least in Germany. And this is seriously where I come from. My name is Maifir. I do work for Lightbend, and I try to be a developer advocate. Actually, that's not my main profession because I've been a software architect for almost 14 years by now. And I've been working with big companies on very, very large projects for almost all of my professional time. And at some point, back in the days, I started to write a little blog. And I wanted to share whatever I learned during all the times that I've been sitting in a dark basement room with customers and trying to make the impossible happen, right? And those knowledge sharing over time became a little profession. So the blog grew and I got more readers. And I started to give my first conference talks, obviously in German first. And I started to travel a lot, and I'm speaking a lot. Last year was like 35 conferences in total, but you've probably not seen me so far. And I have to admit, this is my first Scala days ever, and the reason for that is pretty simple, because I'm a Java champion, and I'm not able to write a single line of Scala code if I don't copy and paste it from somewhere. The funny part is that microservices is such a big topic that we all want to learn about. And especially the Java community, especially the enterprises out there, they are driving the modernization approaches behind microservices at the very moment. And the reason for that is pretty simple, because they've been actually locked in on something called application servers for many, many years. And I'm pretty sure that at least a couple of you had to deal with that kind of monsters in the past. It looked pretty decent, right? It's still hardly readable. It's still a lot of annotations. It's a lot of RESTful. It's a lot of evangelizing J2EE, Java EE APIs out there when it comes to microservices. And this is pretty much the first thing that you read about when you start to research your own information around microservices. Somebody is telling you all you have to do to slice up your monolith is to exactly slice up your existing working application into individual REST endpoints and chain them together again in some way. And this is not exactly true. I mean, just an example at that point. If I would like to access another REST endpoint from my own REST endpoint, I will have to start to hard code stuff in there. I would have to hard code the other REST endpoint's URL. I would have to actually query that, like as a client on the server. There are so many architectural wrongs in this example, I couldn't even name them. And thinking that a little bit further than just with that fancy Java EE example here, what does that actually mean if I'm going to deploy a Java EE microservice? It's not like the one file, right? And it's not easy. We are going to package everything up in an endless chain of jar files, zip files, put everything into this magic application server thing. And we have a virtual machine, we have an operating system. This is insane, isn't it? Seriously? Do I want to run a single REST endpoint with a complete stack somewhere? This is why Java EE applications have been very successful in enterprises, because they actually were able to build out a process around those things. Putting a monolithic application in production at a reasonable 3-letter shortcut company in Germany building autos and cars took actually 18 programmers, 4 business analysts, keep counting, 2 project managers, 6 quality assurance engineers, 3 DBAs, 2 compliance officers, and no less than 6 operation guys. Whoa. So this is the thing we're going to slice apart, right, as microservices, and we're going to make it better. What is actually happening here? If we're slicing up one of those old monolithic applications, the exact opposite happens of what everybody wants to tell you right now. The complexity is just totally blowing up. You have a ton of teams, and you need to actually make that whole thing work. So Java EE application servers in that kind of enterprise-y settings with that kind of big teams is senseless, right? That's the point. And we have to admit that breaking up the monolithic applications is really needed today for many reasons. Back in the days, we had a web browser, we had a server, we had all our logic on the server, everything got rendered. Today, we're using like mobile devices. Even my car talks back to his manufacturer and delivers data. And the worst case is they call me and tell me something's wrong with my car. What do you believe is doing all the magic in the back end? And it's not only my own car, it's 20,000 millions whatever cars, and they're all talking to some kind of backend. And just imagine that cluster of Java EE application servers and the trillions of people you need to make that happen. Obviously, the architectural approaches of yesterday are to be modernized. And I think those two worlds, like talking about microservices, talking more generally about modernization, they just happen to clash and happen to fit very nicely into each other. And this is why microservices is such a thing right now, and everybody's trying to jump on the microservices wagon. I am letting go of Java EE at that point, so feel relieved. What I still want to do, I want to try to explain why microservices are so attractive to enterprises, to customers at the very moment. Software really creates value when it is put into production, when it is running, when customers can order cars, when I can do whatever I want to do online. That's where software starts to sell back its initial investment. If you look at the classical monolithic system that we've been building for 16 plus years by now, and if you look at all those people behind it, it definitely takes 6 to 9 months for some companies to bring changes into production. And this is not like, that's not acceptable, but it's, as a matter of fact, the only way they can do it. And they are pretty proud about their perfect processes, and everything is quality ensured, and nothing happens. And 3 DBAs look over every database schema change. So everything works. But it would be a lot more attractive to be able to stage something into production on a daily basis. A lot more, even for those companies, it's even more interesting to have something productive in 12 weeks. Like everything that makes it faster. Business value is not the only reason. I mean, the requirements actually change a lot. And I mean, I can only speak for Germany or the EU, but if something happens, like in the insurance market, and we get new regulations from the European Union, stuff has to be changed in less than 9 months. This is something that is going to be in effect in 2 months, for example. And just imagine a mainframe in the basement. That's just no longer working, beside the fact that nobody wants to have a mainframe in the basement, but that's another thing. Even 12 weeks would be perfect. And if we could size down the deployments and the production setting units, the services, we would be highly flexible. We would be very efficient, which is obviously one thing that Germans can do best. Am I allowed to tell a joke about Germans? I am a German, I do, right? How many Germans does it take to change a light bulb? I'm listening. 3. It's actually 1. We are insanely efficient and don't have any humor at all. So the point I'm trying to make is whenever somebody is talking about microservices, the assumption is that they are talking about one REST endpoint, that they are talking about breaking apart a teensy little bit out of something insanely big. And this is, honestly, this is the easiest thing you could do with every technology on the planet, even JavaScript, Node.js. Absolutely perfect. But if you start to build a system out of those individual composable units, it is going to be a hell lot more complicated. And this is probably the first thing to really think about when you start to work with the microservice architecture approach. Don't make easy assumptions at that point. REST is a very easy protocol, and JSON is all over it as a data format. Even in the database, if you look at low SQL solutions today, like document-centered databases. But it's just not really effective. And the way classical architects tend to refactor, modernize their monolithic applications, they're just cutting them apart, putting REST endpoints all over the place. They are looking happy. But if you start to chain those REST endpoints, you get insanely long response times, which is like an obvious reason. That's network calls in between, right? And I've seen a lot of patterns evangelizing all kinds of microservice chaining things and chaining patterns. When we're talking about REST over HTTP, which is like the basic assumption that everybody does, even if REST is just an architectural style, this is impractical. It's not going to work. But how should we actually build microservice-based systems? I keep telling you what not to do and what is definitely going to fail, but how do we really want to build our applications? I like this Gartner quote. I mean, I pretty much spent all of my professional career in Java EE, in a traditional application architecture platform. Something that I loved back in the days because it was so easy for me. I didn't even have to think about transactions. I didn't have to think about threads, threading, whatever. If I just had a reasonable amount of workload on that machine, everything was fine. And Gartner says, whatever we've been doing for 16 years and more is dead now. And you know that I've been an architect, right? So one of the guys painting PowerPoints and whatnot. I have to admit, I've always tried coding, and I've always been part of my teams. So there's been at least one feature, no matter big the team was, that I've been responsible for and that I had to implement just because I wanted to. I just wanted to understand what's happening here. I didn't really want to be a PowerPoint architect. And the one thing I learned during those modernization projects is that the basic architectural principles that we all probably know are still very valid. And if you look into microservices, I have to admit, they matter even more today than yesterday. It is insanely important to think about each of those. And I'm pretty sure you have seen them, like loose coupling, separation of concerns. That's been the base of what we're doing in software development since 1992. I don't know, like ever, at least as long as I can think. And you really have to realize that there's nothing rocket science, nothing magic about microservices. It is a solid system architecture that you have to implement. And you can easily use and reuse the lessons we learned from SOA-based installations. All this knowledge isn't wasted at the end of the day. Microservices are just smaller. They are just a little bit different. But how do we get there? Like, how do we cut the monolithic application? The first experience are telling us that domain-driven design is a very good fit. We need to identify individual services in their contexts. And this is exactly what domain-driven design helps us with. If we're looking at traditional architectures, which are layered into front-end, business, and persistence, this is not necessarily something that helps transitioning into a domain-driven design approach in general, mostly because the data models underneath are totally messed up over the years. Average runtime for an enterprise system in Java is easy 10 years. Putting that into a new architectural approach, a new design approach, literally is no longer a refactoring, but a rebuilding. But there are other things that just doesn't work anymore. If you think about the amount of data that's processed from those applications today, and you think about JDBC, and you think about classical queries over blocking APIs. I mean, who had a debug like a JDBC issue in code ever? Probably, right? And it's always been performance related. Something didn't work. And this is when the DBAs came in. They optimized the database for the performance issue related case. And we all know that you can only optimize a database for one thing, either for reads or for writes. You can't actually have both easily. So whatever happened, it influenced the other side. And this is another thing that microservices that are being called frequently and chained and accessing all kinds of domain objects that are persisted do differently. They need to have a read and write side mostly, and they really need to be comparably fast. I don't want to have like long run times. We're not talking about accessing a back-end system, a mainframe, and having transactions that run for more than 2 minutes. What's the longest time you stare at your phone when you look at Facebook and try to refresh? 5 seconds. I think the average is, according to Nielsen Group, below 3. If we have to wait for something on our phones to happen longer than 3 seconds, we're just not using it. And imagine a service that takes that long just because he has to persist a really complex data graph down to the database. That's not working. So we have actually solutions for that problem. One of them is CQRS, the command query separation. We have a read side, we have a write side. It's a very unusual pattern in the classical enterprise Java EE/Java world, but it works pretty well for microservices. And hardly anybody does it right now. Another concept are transactions. I love application servers. I could send a message, I could persist the data, an entity into my database, and I could just have a transaction boundary around it, and I had nothing to do with it. Most of the time, it just magically worked, hopefully. And it did. But if we have services like, does REST as an architectural style and as an HTTP implementation support transactions? No. How should that, I mean, enterprise, if I buy a BMW online, I'm pretty sure BMW is insisting on getting their money. I mean, they can't just drop money because the payment service is not available. Eventual consistency has various scenarios and even new business requirements that we need to take into account. This is something that classical application designs just did differently in the days. So we don't have transactions, usually in microservices. We need to find a way to deal with that. One of my favorite examples to explain that is actually Amazon Prime. So Germans are a little bit laid back when it comes to technology adoption. Americans are way ahead when it comes to that. But I got actually Prime very early. And they have one of the first microservice-based architectures underneath, like Netflix also. So it seems to be a very good idea to use that. I think that's where the hype started initially. And when you buy a movie on Amazon or rent one, and the payment service is not available, what happens? Do you get your movie or do you get an error? Right. Amazon decided in the first couple of years at least, where they started to experiment with that, from a business case, it's even more important to us to have a very satisfied customer than to gain money. So they are giving away a movie for free, just to make you happy as a customer. Again, the BMW example, that's probably not going to work everywhere. And especially in enterprise settings, it might be very challenging to implement those new business ideas and models. And I acknowledge that. But still, it's something that we could definitely work with. If we can't find those new business requirements, we definitely need to work with something like compensating transactions or events that roll everything back that we did so far. Also, very interesting. The most important part, I think, is that we need to build flexible systems from now on. So the biggest concern is no longer efficiency and robustness. It's more embracing failure, embracing resiliency, and starting to build a system where it can really pull apart an individual service without breaking down the complete rest of the system. Does that sound familiar? Responsive, resilient, elastic, message-driven? Where does that come from? Mm-hmm. The reactive manifesto, right? And this is a perfect fit for microservices. The ideas that have been implemented around the reactive manifesto are very, very solid guidelines when you start to implement those systems. Great, we're done. We're done here. Let's meet Offstage. I mean, Scala, Play, they're all great. And they're all just a perfect fit, right? So we don't really need to care. But I have to admit, I told you I'm a Java developer, so I never really looked into Scala, and I never really looked into Acker, even if there's always a Java API. It's not, we could do better in documenting them. I agree. Taking complaints. So you had to build a lot around. And we have a lot of successful customers who did exactly that. Build a microservices-based architecture, a successful system with the existing tools out there. If you don't want to build something yourself, and if you are not really familiar with the tools you're using, and with the tools that would be an obvious good fit in that whole setting, what do? You come up with a new idea, and you try to make everything a little bit easier for everybody. And this is where exactly the direction where Logon is heading into. And Mirko Dotta, a coworker of mine, he was giving a very deep dive technical talk just before my session in another room. But knowing that every session is going to be recorded, so I highly recommend re-watching his session. Logon is actually built around developer experience. I'm not saying that it's trying to be as convenient as application servers went over the years, but instead of just having 20 million terminals open and starting individual services and not having hot reloading features like stuff that we really got used to over the years, Logon comes with a developer mindset. If you have a microservice-based system, 20 services, and you run your system with Logon, Logon fires up everything you need, including the databases and the individual services. With a gateway, it's perfect and easy to manage. And you don't actually have to have a bunch of scripts around, which is something that we probably all did to start services in that case. And it also takes you through the production, which is kind of the most important part. If you have just a bunch of fat jars that you would need to package up in a Docker container and deliver them and make sure everything is wired correctly together. There's a lot of work that Logon actually, in combination with Conductor, takes off your plate in those projects. And if we just peel away the marketing label, this is the list of technologies that are in Logon. This is pretty interesting because it says Scala here. Logon is built with Scala, but it doesn't have a Scala API yet. So for the moment, it's Java API first. That shouldn't hinder you looking at it. We have a couple of examples out there, how to use Logon services and APIs from Scala. So you can do that, it's just a little bit of a workaround. What is in Logon? What is really the great thing? The great thing is that Logon doesn't try to solve all your problems. As a matter of fact, it's highly opinionated. And it really wants to give a very top-level guidance on building microservices the right way. And nobody really likes the word microservices, by the way, because it implies that the service needs to have a specific small micro size. But size in terms of services is probably the worst thing to look for. The first couple of sessions I gave about microservices, the number one question I got asked was, how big do you think has a microservice to be? 20 lines of code? And I was like, seriously? You're really asking that question? I like to call them Logom services from here on. And Logom is actually a Swedish word, and it stands for just right or just the right amount. And that's a pretty perfect translation because we should be looking for right-sized services and no longer for services that try to imply any size regulations like lines of code or whatnot. So we have basically a service API, which helps you with I/O and communications. Streaming between services is one of the most important parts. It's all based on Akka streams, stuff that we all know and Java developers didn't so far. It makes it pretty easy to use, and it gives you a built-in resiliency just by using those tools and giving you the guidelines. Like it's your manual for microservices. This is what Logom tries to be. And the service is actually a bounded context according to the domain-driven design architectures. You have clients, you have endpoints. If you want to have a code deep dive, again, Mirko did that perfect. And the other thing that Logom provides is actually a persistence API. And this is not slick. This is not something that we already had so far. This is a very solid and nice implementation of the CQRS event sourcing model. And Logom comes with a very easy usable database underneath, so Cassandra is built in. You can swap it out, that's not an issue, but it works pretty well. And you can just persist your domain entities and send persistence events. So you can replay state. It makes it comparably easy. The development environment, I have no idea what you expected, but as a matter of fact, it's SBT. So SBT and Logom and a couple of plugins. And that's what makes all the magic happen. And what you see here is basically that run all as a command on your Logom-based project. It starts up your Cassandra instance, your service locator, your gateway, and the individual services. This is the Hello World example that kind of comes with Logom. I have a couple of links for you. What are the next steps for Logom? This is in no particular order. This is no promise. I still refuse to talk about any of them, but this is what we're thinking right now. If you really want to be involved with the project and want to learn a lot more, again, I have a bunch of links here. You can contribute on GitHub. The complete thing is Apache licensed and open. And I highly recommend to contribute, give feedback, talk to our engineers on the public channels. We actually have a public mailing list, and I'm pretty sure that everybody can discuss about that further. If you need more background on the principles behind Logon, there's a pretty amazing book written by Jonas Bonner. Yeah, this is the architecture behind Logon. If you want to understand why we did it, those are the reasons. And it's a free ebook. You can download it for free. It has like 60 pages. Maybe on your flight back home or whenever you have a couple of minutes, this is exactly your read. And there's a follow-up book that I just published and finished, which is the implementation guide. So kind of as an apologize for not showing code or doing a demo today, I basically wrote a book and made it free for you. I hope that works. It's the first time I ever did that. You get the slides afterwards anyway, right? So you have access to all the links. If you want to start over, project site is on lightbend.com/logon. You can work more or less directly with the team on the GitHub repository. Everything's open and transparent. And the documentation is just insanely great. That's all I can tell you. So you're totally free and happy and welcome to check it out and learn. It's very, very easy. And I think we have a couple of minutes left for question and answers at that point. Yeah?
Do you have any best practices for handling versioning within microservices environment?
Best practices for handling versioning. There are a couple of approaches. Logon doesn't really have one right now, at least not on the API level. You can basically go API level, you can go service versioning level, you can go source code versioning level. I think the most practical thing is to have something in the descriptor, interface descriptor, or have an API management solution in between. Thanks for your time. Enjoy the conference.